Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 6, 2026, just 4 days ago. It introduces a new evolutionary method utilizing GPT 5.2 that achieves an annualized rate of return of about 28% on the China Securities Index 300. The paper is titled QuantaAlpha, an evolutionary framework for LLM-driven alpha mining. And as we'll see later, the system's ability to transfer these learnings to the S&P 500 is really impressive. And for those interested in the implementation, the authors have shared their code on GitHub. Well, Figure 1 illustrates these cumulative excess returns on two out-of-distribution markets, the CSI 500 on the left and the S&P 500 on the right. The top red line represents QuantaAlpha, which notably maintains an upward trajectory even as other methods begin to plateau around late 2023. By the end of the evaluation, the model delivers roughly 160% return on the circa SI 500 and 137% on the S&P 500. This is significant because the factors were mined on the circa SI 300, so these gains come from zero-shot transfer without any specific retraining. Well, Figure 1 showed the results. Now Figure 2 breaks down how QuantaAlpha differs from previous methods. The top row represents traditional machine learning models, which act as black boxes with sealed parameters, making their predictions unexplainable. The middle row shows standard agent baselines. These use large language models, but often get stuck in loops, effectively shrinking the search space. In contrast, the bottom row details the QuantaAlpha framework. It treats mining as a trajectory, using self-evolution mechanisms like mutation and crossover to actively expand exploration while keeping the logic traceable. So, Figure 2 just highlighted the difference in approach. Now, Figure 3 details the actual four-stage architecture. It starts in the top left with diversified planning initialization, where a large language model generates distinct market hypotheses from a seed library. Moving down to factor realization, these hypotheses are converted into executable code. Crucially, they pass through a constraint gate, checking for logic and redundancy before being backtested. The real engine is the self-evolution strategy on the right. This applies genetic algorithms. Mutation refines a single trajectory by fixing specific flaws, while crossover combines the best parts of two parent strategies. Finally, validated factors land in the final factor pool shown at the top right. Alright, after Figure 3 detailed the architecture, Table 1 presents the quantitative results on the CSI 300 market. The table is split between classical mining methods in the top section and large language model agents in the bottom section. QuantaAlpha, specifically the GPT 5.2 run highlighted at the very bottom, secures the top spot across almost every metric. It reaches an information coefficient of roughly 0.15 and an annualized rate of return of about 28%. For comparison, the best deep learning baseline only manages a 7% return, showing just how effective this evolutionary strategy is. So, while the previous table showed the final score, Table 2 performs an ablation study to see which parts of the engine matter most. The first data row establishes the baseline with the full QuantaAlpha model achieving nearly 29% annualized return. Crucially, look at the third row, where mutation is removed. This causes the steepest drop, slashing returns by almost 10% and hurting predictive accuracy significantly, which confirms that the mutation mechanism is the primary driver of performance. Removing the planning phase, shown in the second row, also hurts stability, increasing the maximum drawdown to over 12% because the system starts with less diverse hypotheses. Well, Table 2 showed the stats, but Figure 7 brings the process to life with a case study. The red line tracks performance climbing from 13 to 30%. Starting at the bottom center, Iteration 1 sets a baseline with a simple hypothesis. Then, looking at the left panel, the mutation operator in Iteration 2 detects a flaw and rewrites the code to add risk control, boosting returns to over 19%. Finally, the box on the right shows Iteration 5, where the system evolves a robust institutional momentum strategy to reach the peak. Wrapping up, two main takeaways stand out. First, QuantaAlpha shows that applying evolutionary operators like mutation and crossover allows models to refine trading strategies logically rather than just generating them randomly. Second, its strong zero-shot performance on the S&P 500 indicates it captures fundamental market structures, making it highly robust to regime shifts. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.